Welcome to Spring LIB.
This is Chapter 12, Problem number 12 from the Smith Organic Chemistry textbook. And this problem is asking us to treat this starting material, which I've drawn up here, with 4 different sets of reagents and determine the products under each set of conditions. And so A is asking us to treat the starting material with excess hydrogen gas and just regular palladium on carbon. And so, of course, the result of that is going to be complete hydrogenation all the way down to the alkane. And so I've drawn the affected carbons in red just so that they are easier to pick out. And you can see that it's gone from C triple bond C to just CH2CH2, and it's just a typical alkane. So the next part of the problem, B, is asking us to treat the same starting material, but this time with 1 equivalent of hydrogen gas and using Lindlar's catalyst instead of just palladium on carbon. And so we know that Lindlar's catalyst is going to produce a cis alkene. And we also know that Lindlar's catalyst is not going to allow for the further reduction of that alkene to an alkane. But also, just to reinforce that point, we only have 1 equivalent of hydrogen gas. So theoretically, we could only do 1 reduction anyway. 1 pi bond reduction anyway. And so that's what I've drawn here, the cis alkene product. And again, the affected carbons are highlighted in red. So then for C and D, again, I drew the starting material up here just because it's easier to keep track of that way. And so C is really asking the same thing as B, but this time we have excess hydrogen gas. So we have as much hydrogen gas as we want, but the product is actually still identical to B, the product of B, because again, Lindlar's catalyst is not going to further reduce an alkene. And so we do the single pi bond reduction to get from the alkyne starting material to this cis alkene with Lindlar's catalyst, and that's it. So no further reduction there. And then for D, we're asked to do a dissolving metal reduction. So that's sodium metal in liquid ammonia. And remember, this is complementary to Lindlar's catalyst because this set of reagents is going to give us the trans alkene product. And so that's what we have here for D. The product is the trans alkene from the reduction of the alkyne. And again, that's because a dissolving metal reduction gives us a trans alkene product. And so that's what we have.